All right, hi. We're doing an Aipd course, Army Institute Professional Development Army Correspondence Course Program. Subcourse QM3504, Edition A, Direct Gaging and Sampling Operations. Lesson 1, Gaging Petroleum Storage Tanks, Critical Task 01-5103-000036. Introduction. With the exemption of new light divisions, today's combat forces incorporate highly mechanicalized mobile weapon systems that require vast amounts of fuel to operate. Many battalions have their own garrison, bulk, petroleum storage dispensing facilities, and in addition, with the fleet of bulk refuelers to satisfy the highly demanded rated as quartermaster officers, you may receive an assignment to one of those battalions. Assume responsibility for battalion's bulk storage tanks as a part of your duties. You're transferred to the Combat Service Support Battalion. Handles millions of gallons of petroleum products a day. As a quartermaster officer, you must know how to accurately account for the fuel. Although you're rarely involved your personnel in accurate process of gauging, you must know and understand the procedure effective supervise your patrol personnel. One, gauging measures the height of the liquid level above the bottom of the tank. Innage. The height of taking a reference mark above the liquid level fuel is outage. As part of the determinant of the volume of the contents of the tank, they often hold the bulk petroleum products many times before you use them. Make sure that originally account for them throughout the handling, that you maintain accurate records at all times. The accounting purpose: make sure personal gauge products periodically determine the quantity on hand, to verify the quantities issued received, to detect leaks, and determine the terminal capacity of receiving the shipments. 2. Gauging. The following terms are used discussing gauge: innage, outage, reference point, datum plate, reference height, tape cut, bob cut, tanker truck capacity, opening gauge, closing gauge, bottom sediment, water, BNS and W, total measured quantity, gross quantity of product, and net quantity of product uncorrected. The innage is the depth of the height of the volume of the product in the tank measured of the gauge from the surface of the product to the bottom of the tank. Outage or ullage. The outage or ullage is measurement of the free space above the surface of the product in a tank extended from the reference mark. The reference mark. The reference mark is a horizontal line put on the rim of the gauging hatch on the tank representing the fixed point with the measuring of the made. The datum point is a level metal point with the tank bottom directly under the reference mark. The plate provides a smooth level surface from the surface of the innage bottom bob to the rest upon when it taking an innage gauge. Reference height. The reference height is the distance from reference mark to the top of the datum plate. After you establish the reference of the height, stencil it in a conspicuous place adjacent with the gauging of the hatch. Tape cut. A tape cut is the line made on the tape measured from the scale by the product being measured. A bob cut is the line made on the bob by the bottom of the sediment of the water being measured. Tanker truck capacity. Tanker truck capacity is the amount of the product of the vehicle where the product reaches the adjustable marker installed beneath the dome of each compartment. Adjust the mark in relationship to the type of the movement and the highway or cross country. Opening gauge. The opening gauge is the gauge of the product taken before the delivery, issue, and receipt of the product. Closing gauge is the gauge of the product taken after the delivery and issue and the receipt. Okay, the bottom sediment and water. Bottom sediment, water, BNS and W is the amount of sediment, water measured in the bottom of the tank. The total measured quantity of the volume of the product in the bottom sediment water in the tank, of the observed temperature of the product, of the timing of the gauging. Usually obtain the measurement from the tank's capacity table and stripping chart. No, engineers develop tank stripping charts when they're constructed tanks. Simply strapping charts are conversions tables that convert linear measures taken from the tape and the bob. Reading of the equivalent volume amounts. No two storage tanks have identical strapping charts because the tanks of the same size vary in capacity. Gross quantity of product. The total measured quantity minus the bottom sediment and water is gross quantity of the product, known as the net quantity or product uncorrected. The net quantity or product corrected. The net quantity of the product is corrected as measured quantity of the product minus the bottom sediment water, and it observed the temperature converted to an equivalent quantity of 60 degrees. Gaging equipment. The paragraph describes the special equipment needed to measure bulk petroleum, tape, and bob. There are two types of tapes and bobs currently used: an inch tape and bob and an outage tape and bob, using them to measure the amount of the product in a tank. Each consists of a metal bob connected by a harness snap of the steel tape, graduated with one side to 1/8 of an inch division of hose in a reel. The inch tape and bob. The inch tape and bob is a steel tape with a 1/8 of an inch graduation. The first whole number of the tape is 9 or 10. Consequently, it is 9 or 10 inches from the point of the top of the conical bob. The first number of the tape from the tip of the bob onto the top of the eyelight is 6.6 inches. The bob is made of non-sparking metal with 0 point of the bottom bob's tip. Refer to Figure 1 for the illustration of the inch tape and bob, using the inch tape and bob to determine the distance from the surface of the product to the bottom of the tank. All right, you see your inch tape. You see a handle of tape at the crank, and it's a bob, which is 10 inches from the top of the tape, with the bob, the eye, and the harness snap. Outage tape and bob. The outage tape and bob, shown in Figure 1-2, looks similar with the inch tape, except for the readings being at 3 inches level on the tape. 0 reference whether the harness snap connects with the bottom of the 6-inch long rectangular bob, 1/8 of an inch graduation, starting with the 6-inch mark at the bottom. When you read the upward to 1 inch of the last whole number on the tape on the top. The outage of the bob has a flat nose and is made with non-sparking metal. Use the outage tape and bob to determine the distance from the surface of the product to the top of the tank. Alright, your outage tape shows the handle, the tape, and the crank, with your bob 7 inches, and then the eye, and then 3 inches from the eye to the tape, from the eye and the harness snap, marking 0 inches. The indicated indicated pace. Fuel and water indicated pace is issued to determine the amount of the respective liquid of petroleum storage tanks. Fuel indicated pace, indicating pace. Fuel indicated pace is a petroleum base pace used in measuring the amount of liquid petroleum in the storage tank. It changes color when it comes in contact with the petroleum product. A water indicating pace. A water indicating pace is a chemical pace using differentiating between the liquid petroleum products and water. The pace changes color when it comes in contact with water, but not affected by petroleum products. Gaging sticks. Using a stick to gauge tanks and tanker cars and tank vehicles. Tanker car gauge stick. The tank car gauge stick is varnished piece of wood or other corrosion-resistant material, approximately 3 feet long, from the outage gauge tank cars. The stick has 2 scales graduated in 1/8 of an inch divisions, with a common 0-12 inches from the lower end. Attached to the stick is an angle. When you place the stick with the angle resting on the upside of the tanker car shell, the 0 scale coincides with the underside of the shell. The petroleum gauge stick, a gauge pole or stick varnished with a piece of wood or other corrosion-resistant material used in an inch gauging small sanitary tanks, tank cars, tanker trucks, using a pole that is long enough to gauge to the tank, approximately 10 feet for a railway tanker car. To prevent damage from to the wood poles, use an aluminum tip cap, or one side of the pole has been scaled, graduated in feet in inches to the 1/8 of an inch division. The bottom of the tip is 0 point. 3. The truck vehicle gauge stick. Each tank vehicle has its own gauge stick graduated with a 25-gallon division instead of the feet and inches. The product is between gallons and divisions. You interpolate. Gaging precautions. Procedure gaging per tanks are according to AR 710-2. Observe gaging precautions and procedures during gaging. Gaging precautions. Follow the precautions on gaging tank gauge bulk storage tanks before and after any receipt, issue, or transfer operations. Ground the static electricity by touching the bare hand to the tank and shell and handrail before climbing a tank before performing a task. Open a gauge hatch, allow vapors to escape. Do not stand on the roof of the tank when gaging. Performing the gauge from the side of the gauge hatch which has the wind to your back if possible. Be careful not to breathe the vapors from the contents of the tank. Never perform gauge during an electrical storm. Requiring the gauge personnel to stand at the same location of the roof, on the roof, but both the opening and closing gauges if they must gauge while they stand on the tank's roof. Perform the record gaging on the nearest 1/8 of an inch. Repeat the gaging until you get two identical readings. Be certain that the tape touches the rim of the gauge hatching all times to the ground static electricity during the gaging process. Wipe the tape clean and dry after use. After discharge of the product into a tank, let the product stand for at least 30 minutes to eliminate all static electricity before gauging it. Take the product temperature reading from the volume correction before and after receiving issue volumes of 3,500 gallons or more using the same tape and bob for opening and closing gauges. If the time permits, allow a 2-hour settling period for adding fresh stock to storage tank. Gauge all bulk deliveries for water bottoms before receiving the product. Drain off any of the water found. B. Inch gauging. Using an inch tape, the bottom bob to open the height of the product of the tank. Follow these steps to retain the inch gauge using an inch tape the bob. Direct the inch method of gauging atmospheric or other non-pressure tanks. Raise the appropriate hatch and cover lower. Locate the reference point shown in Figure 1.3 and this point A. Apply the water indicated with the paste to the bob. Do not point. Apply graduation portion. Apply the production and induction paste to the tape level of the product in the tank. Apply the paste then thinly with the graduated side of the tape. Ensure that you have hold the ungraduated side of the tape at the contact with the metal rim of the gauging hatch the metal rim of the gauging hatch at the reference point as you lower the tape into the tank. Alright, this shows the inch tankage going in at the reference point at the top of the lid, following the inch tape with the product tape with the cut. Product level with the reference height A, B, and C being the bottom, B being the product level, and A the reference point at the top. Following the inch tape to the product of the tape cut to the product level, the inch bob in the water tank of the datum plate. Lower bob and tape in the tank until the tip of the bob just touches the tank bottom of the datum plate. The horizontal plane at the level of the point C. If the lower the tape is too far from the bob tilts it, you obtain an incorrect reading. Compare the tape reading to the reference point A in Figure 1.3 to reference point H. Compare the tape reading to the reference point A in Figure 1.3 to reference height, the distance of point A to point C in the Figure 1.3 of the container to ensure gauge accuracy. Withdraw the tape of the 30 seconds and read and record the product tape cut on the tape of the inch gauge. Read and record the water cut on the bob of the bottom sediment when water cut. Ensure that you obtain the identical readings to gain accurate measurement using a sample gauge and equipment gauging the hatches, obtaining the opening of the opening and closing gauge. Be sure to lower the tape in the same depth on both gauges. The outage gauge method. The outage gauge method with engaging barges and tankers or tank AMRSs also use outage gauge method to obtain the amount of space for the ullage remaining in the tank. You should use all the safety precautions. You may use the method of the storage tank when necessary to get an outage or ullage measurement using an outage tape or bob. Follow these steps. Ensure that you apply the product indicated with the paste length on the bob. Hold the unmarked side of the tape against the metal rim of the gauge hatching, the reference point A in Figure 1.4. Lower for the tape and bob into the tank until the bob touches the surface of the product at point B in Figure 1.4. Wait until the bob is motionless. Lower the tape slowly until the bob is 2 or 3 inches below the product surface at point B in the Figure 1.4 presents the product of the surface. Record the reading of the tape at the reference point A in the Figure 1.4. As the tape reading, withdraw the tape quickly. Record the product cut as on the bob as the bob reading. Read the scale of the nearest 1/8 of an inch and less than 1/4 of an inch reading applicable. If the product cut is hard to read, then the product indicating paste on the bob and the gauge and take again. At the bob reading of the tape reading of the gauge outage gauge, subtract the outage gauge from the reference of the height of the tank. The converted outage gauge into the inch gauge to the inch outage gauge to the inch gauge. Follows the example shown to how to perform this step. Examples: use 1/4 inch readings to tape reading in reference point at 21 feet 6 inches. The bob reading plus or minus 3/4 of an inches, and the outage gauge at 21 feet 9 foot 3 inches. That's plus 3 3/4 inch bob reading. All right, you have your reference point and figure, and the reference point, the inch gauge, the inch bob, the bob cut, the product level cut, the coated with the fuel indicated pace, the shell outage, the reference height for your outage, and then you have your reference shell outage, reference point, outage tape, outage bob cut, product level, and coated with the fuel indicating pace. No, if the tank is gauged with the calibrated only if the tank being calibrated to only an inch measurements, convert the outage gauge to an inch gauge using the following procedures: use an outage gauge above 20 foot, 9 foot, 3¼ inches, and assume the reference height of 50 feet. In actual practices, use the reference height of the tank being gauged. The outage gauge of 21 foot, 9¾ inches, and point A to point B. The reference height is 50 feet. Point A to point C. The inch gauge is the distance between point B and to C. To convert the outage to inch supply, simply subtract the outage from the reference point. And an example of the product is follows: height and distance inch gauge 50 feet or 21 minus 21 foot 9¾ inches, 28 and 21¼ inches. Perform the bob cuts with the bottom sediment water using an inch method. Only use an inch bob. Bottom sediment waters. Storage tanks containing liquid petroleum products are measured with the bottom sediment water. Each tape at the time that they are gauged and determine the actual point of the product. Figure 1.5 shows how to use the bottom sediment water measurements. Bottom sediment and waters accumulate in different parts of the tank bottom. They usually accumulate on the side opposite of the filling line or either side of the outlet. When the tank has several hatches, gauges from each hat, average them to the bottom sediment water gauge for the whole tank. Follow these steps to measure the height of the bottom sediment water. Use the water indicating paste to determine the water. Put in the thin, even coat paste on the part of the bob that touches the point where the water product meets. Be careful not to put too much, so much that the bob can cause the false reading. If the depth of the water is greater than the length of the inch of the bob, apply the water indicating paste to the lower portion of the tape. Measure the water in the tank. Hold the side of the tank against the metal rim of the gauging hatch and at the reference point. Alright, so we're checking the water page. You got paste on the water that shows you have your reference points. A and B, the bottom of the tank, the top of the tank, and B, the product level. And from the A to B, you have the inch tape, the product tape cut, the product level. And from B to C, you have a water inlet, a sediment, water, and then your water imagement from the datum plate on the image gate coated with paste with the water cut. And then to the product level, if there is any, if the water's past the bob, then coat the tape. Lower tape of the bob in the tank until the bob is short with the distance of the bottom. Determine this as comparing the length of the unwound tape with the reference height of the tank. Unwind the tape slowly until the tip of the bob touches the tank. Bottom of the datum plate. Do not let the bob rest on the rivet, otherwise, or other obstructions. Do not lower the tape so far that into the tank that the bob tilts, causes an incorrect reading. Keep the tape in the bob engaged position at 5 to 10 seconds of kerosene, gasoline, or other light products. Keeping position for 15 to 36 for heavier products. Removing the tape in the bob from the tank portion of the bob waste in the water should show the discolorization. Record the water cut as the bottom of sediment and water. Temperature measures. Because of the volume of the petroleum products increase and decrease, the temperature change. An accurate measurement of the temperature of the product is taken when you gauge it. Then you can correct the measured quantity to the standard temperature of 60 degrees Fahrenheit, volumes over 3,500 gallons. When gauging large quantities, you take the temperature reading of the various levels of average, determining with the true temperature of the product. Figure 1.6 shows the number of the readings necessary at the level at which to place the tank thermometers. Alright, the depth of the product of more than 15 feet, and the minimum number of temperatures of 3 feet below the surface of the product, middle of the product, and 3 feet above the bottom. 10 to 15 feet, depth of the product, and the minimum number of temperature measures, 2 feet, 3 feet from the surface of the product, 3 feet from the bottom. Less than 10 feet, one temperature thing from the middle of the product. Use the cup case thermometer to measure the temperature of the product of the storage tank. The thermometer is attached to the hardwood backing the base of the mercury column extended within the cup base. When filled with liquid and under the measurement, the cup cape minimizes the fluctuation of the reading. When suddenly withdrawn from the thermometer tank, the figure 1.8 shows the minimum immersion time of the various fuels. To avoid the long immersion time, the measuring heavy petroleum fuels leave the thermometer suspended in the tank at all times. Follow these procedures whenever you're measuring the temperature. Examine the mercury column for each of the cup case thermometer separation. Replace any thermometer having a faulty column. Mercury separations cause incorrect readings. Inspect thermometers for accuracy. Expose them as a group then to the same atmospheric temperature. Compare the readings. Replace any thermometer with a reading that differs from the group of 1 degree Fahrenheit or more. Provide all tank thermometers against the reference standard each year. This shows your cup case with the thermometer in it, approximately 16 inches, approximately 1 by 1/8 of inches, and 2 inches. Automotive gasoline, motive gas, aviation gas, and kerosene, diesel fuel, jet fuel, and grades 1 and 2 burner fuels. It takes 5 minutes. Grades 4, 5, and 6 of the Navy Special Burner Fuels, 15 minutes. These columns are Table 4, minimum immersion time of the cup cases, API standards 2543, ACSTM designation D1086, product listing are not comprehensible. Using Figure 1.6 to determine the minimum number of the readings measurement leading levels required for the operation, do find the true average temperature of the product attached to the thermometer to the end of the gauge of the tape, brass coated with a chain or cord. If the cord is tied in knots in the cord so that the knots show whenever the thermometer reaches the required level. Lower the thermometer is required to level there in the amount of the time shown in Figure 1.8. Then take the thermometer out of the tank, read it once, shelter the cup below the hatch, reduce the temperature change caused by the wind and atmosphere, withdraw the full cup of the product from the tank. When taking the reading, do not spill it. Record the temperature to the nearest degree Fahrenheit. When you gauge your large quantities, take several temperatures readings, various depths. All the readings divided the sum of the number of the readings to get the true average temperature of the product. For example, assume the tank contains 20 feet of product. Take temperature 17, 20 feet, and 3 feet, and 3 feet below. The top surface of the product with the middle of the product or at 3 feet above the bottom. Assume that your readings are 82, 81, and 80 degrees Fahrenheit. As these readings divided by 3, the number of the readings to get the average true temperature of the product. 82 plus 81 plus 80, 243 divided by 3 is 81 degrees Fahrenheit. 81 degrees Fahrenheit is the true average temperature of the product in the sample. 7. Volume calculations. Performing volume calculations, quantities of fuel of 3,500 gallons more than less quantities when directed by the higher headquarters. Follow these steps to calculate volume. Obtain the total measured quantity from the tank capacity tables. Obtain the bottom sediment and water is measured by the quantity of the tank capacity table. Subject the bottom sediment and water measured quantity of the total measurement quantity to assure. Obtain the net volume of the product uncorrected. Measure the American Petroleum Institute of gravity appropriate with the hydrometer. Remember to convert the API gravity to corresponding gravity at 60 degrees Fahrenheit. Provided instructions how to perform this conversion is found in paragraph 9. Using the following fuel classifications, API gravity test procedures: draw 300 millimeters on the sample fuel, take the sample, then shelter place to test it, shake the sample to mix it, slowly pour the sample into a clean or dry hydrometer cylinder, filling it with 3/4 full, allow air bubbles to rise, tap the cylinder top with a cupped hand. To remove the surface bubbles, select the thermal hydrometer that has the range close to the API gravity of the fuel. Gentle lower the thermal hydrometer into the sample. Spin the thermal hydrometer to get its rest of the middle of the cylinder away to the side. Wait with the thermal hydrometer float the freeway away from the side, reading the nearest scale division. Point your eye slightly below the level liquid. Raise slowly until the surface of the liquid appears level. To record the reading of the observed record temperature on the thermal hydrometer. The two readings that you take from the thermal hydrometer are observed on API temperature. The DA Form 3853-1 inch gauge sheeting of the DA Form 3853-1 shows the Figure 1.9 to record opening and closing gauge the lineal reading volumetric equivalent in gasoline as well as the observed API used for the correcting quantities at 60 degrees Fahrenheit. Keep this form on the file for each gauging and each inventory as backup data. Alright, now for Figure 9. Observe the gravity correction. Make the API gravity with the correct hydrometer listed in Figure 110. Hydrometer gives the API gravity reading. Observe the temperature reading with the sample. Convert the observed gravity reading from the API gravity to 60 degrees Fahrenheit using the tables prescribed in AR 710-2. This shows the sample inch gauge sheet And then you have your NSNs for the hydrometer, graduate scales, cylinders, cup case, replacement thermometers, and water indicated for these items. 10. Fuel classification. To classify the fuels, the following steps. Compare the corrected API gravity through the API gravity range, particular product. If the corrected with the API gravity compares lower the higher than the product gravity range, the test results indicate possibility of commingling with the product with a heavier or lighter products. If the corrector API gravity is not less than not within range of the fuel being tested, isolate the mark of the fuel in container and the sample of the fuel and send the fuel to the supporting laboratory for analysis. Disposition instruction. Do not use the fuel until receiving the disposition instruction. 11. Volume correction. The volume of liquid petroleum products changes because of the change in the temperature. When the temperature of the product increases, the volume of the product increases. When the temperature of the product decreases, the volume product decreases. Therefore, the corrected gauge for volumes in excess for 3,500 gallons to account for this change of volume. The standard temperature of the volume measured of the petroleum product at 60 degrees Fahrenheit. Measured of the petroleum product at the volumes exceeding 3,500 gallons. Correct the measurement to what would have been 60 degrees Fahrenheit. For example, the temperature greater than 60 degrees Fahrenheit, your measurement shows the more the product if it would be at 60 degrees Fahrenheit. Therefore, you adjust the measurement accordingly. Likewise, the temperature less than 60 degrees Fahrenheit, you might measure less than the temperature, where at the standard 60 degrees Fahrenheit, you just added reading to the standard. Follow these steps to make volume correction. Gross volumes is quantity of the petroleum product, the bottom sediment, water, net uncorrected volume, the measured quantity, and the product amount minus the bottom sediment, water at the to be observed, the temperature before the conversion to the equivalent quantity at 60 degrees Fahrenheit or 15 degrees Celsius. Make sure all the tanks are individual strappings, charts, and calibration takes showing the volume product in the tank of the foot and inch, even the fractions of an inch, usually 1/8, to determine the total measured quantity of the tank of the product of the bottom sediment water. Using the sample stripping chart to be uncertain with the gauge determines the volume of the water and the tank of the volume of the volume. The charge, the permanent product is left. Remember the safety subtract volume. The volume never in inches or from inches. The resulting figure is observed, but the temperature reads to be corrected with the volume of 60 degrees Fahrenheit. To determine the multiplier necessary to convert the volume observed with the temperature at the volume of 60 degrees Fahrenheit, you need to average the tank of the temperature API gravity of the product. Use the following, for example, to making the volume corrections. Inch gauge, tank capacity 500 barrels, tape reading 6 foot 3¼ inches, bob reading 1 inch, measure tank temperature 67.5 degrees, API gravity at 60 degrees Fahrenheit, 56.3 JP4, converting gauge readings to the gallons. Refer to figure 111, convert the bob cut of the 0 feet to 1 inch to 45.41 barrels. There are 42 gallons per barrel. To calculate the number of gallons, multiply 541 times 42 gallons per barrel. That results in 227.22 gallons. Note the actual practice. Refer to the chart for specific grit tanking and being gauged. Refer to figure 1.1 to convert the tape of the cut to 6 feet 3¼ inches or 17,096.52 gallons. Since the figure does not list the 6 foot 3¼ inches, you need the quantities of 6 foot this need, and then 3 inches for 1/4 inch. Then add the quantities. Figure 111 shows the 389.48 barrels for 6 feet or 16.23 barrels for 3 feet inches and for 3 inches. 1.35 barrels for 1/4 inch. Some of these measurements are 407.06 barrels or 7,096.52 gallons. Again, actual practice, you would use chart for the particular tank being measured, not in figure 111. Note that your determined uncorrected volume of the tank. To find the tank's corrected volume, find the volume correction factor, figure 112. In order to use the factor, you must know the API gravity of the product of 60 degrees Fahrenheit, rounded off at the nearest fifth of a degree. If the problem is API gravity 56.3, round this figure to 56.5. You need the measured tank temperature, which is 667.5 in this problem. Locate the tank temperature 67.5 in the left-hand column of the volume correction table to figure 112. Go across to 67.5, rounded to the API gravity of 60 measurement of 56.5. Read the volume correction factor from the table at the point at which the temperature line of the API gravity column intersect. The volume correction is 0.9950. Subtract the volume of the bottom sediment water 227.22 from the gross volume 17,096.52 to obtain the uncorrected value of 17,096.52 gross sum and minus 227.22 bottom sediment water. You get 16,869.3 for the non-corrected volume. Multiply the net volume by the uncorrected volume. The 16,869.3 with the volume correction of 0.9950, and you get 16,784.953. Round off the nearest gallon, report 16,785 gallons at the corrected volume. This shows a gauging chart between the barrels and the inches of the depth, and this one shows the API gravities at different temperatures from 60 degrees. Temperatures in Fahrenheit factors converting the volume to 60 degrees Fahrenheit. It shows the API gravities at 60 degrees Fahrenheit, or a factor for completing the volume. Lesson 2, sampling petroleum storage tanks. Lesson 2, sampling petroleum storage units, critical task 01-5103-0039. Introduction. The same response mentioned in the introduction lesson. The subcourse of the quartermaster must be able to identify the different sampling procedures, determine the procedure for the use of the various situations. As a petroleum management officer, you must learn to supervise the sampling of various petroleum products. The lesson provided with the instruction in these areas. In general, the importance of the sampling cannot be overemphasized. Using the sample to determine the quality of the petroleum product. Sample the small amount of the petroleum, which represents the whole product. Refer to the extract of the field manual 1018 shown in the appendix B of the requirements testing and sampling petroleum products. This extracts also include a minimum frequency for such testing according to the product bulk and packaging. As extracts of the field manual 1018 shown in appendix B point out whenever you suspect. Product of being specification testing and sampling. Product of using testing type A and the testing type B. Note that after using the sampling equipment to obtain the represented sample the different petroleum products from the various petroleum containers, ensure that its personal operating base laboratory mobile laboratory petroleum testing kit inspection testing sample and determine whether or not they meet the specifications. Type of sample. The paragraph defines the following type of samples: top, upper, middle, lower, bottom, all levels, spot, composite, single tank composites, multiple tank composites, outlet, average, and drain continuous. Top uses the bottle or breakage similar to the top of the sample, the 6 inches below the surface of the tank of the tank contents. Upper the bottle or breaker sample taken at the upper sample of the middle of the top of the third of the product. Middle the use of the bottom of the breaker or breaker sample taken from the middle of the sample the middle of the product cut. Lower use of the bottle of the breaker or the sample of the lower sample the middle of the bottom of the third of the cut. The bottom of the use of the bacon bomb thumb each sampler to make a bottom sample of the material product with the bottom of the tank. All levels. Take all levels of samples submerged with the closed bottle beaker samples, all closed with the possible with the bottom of the tank or container. Then open the sample and raise it to the uniform rate so that it was 75 to 85% when it comes out of the liquid. A spot. To take a spot sample, specifically place it in the tank. A composite sample combines of the individual samples representing the bulk, and then came from the samples can be in a single tank or the multiple tank composites. A single tank composite sample is blended with the upper, middle, and lower samples of the tank contents. The blend has equal parts of 3 cross sections from the tank with a uniform section, as the upright cylindrical tank has uniform cross sections. Multiple tank composites. A multiple tank composite sample is blended with the single and all level samples taken from the tanker or barge compartment and that contain the sample. The product of the sample consists of the part of the proportion of the volume of the product in each of the compartments sampled. Outlet. The bottom of the bottle of the breaker sample taken with the out of the sample at level of the tank outlet, whether the fixture swinging. The average sample consists of a proportional parts of all sections of the tank. The drain. Take a drain sample from the draw off the discharge valve And the continuous sample from the pipeline will allow the product to collect slowly in a sampler during the entire flow rate. The continuous sample represents the stream of the product during the period it was sampled. 3. Safety. Due to the volatility of the petroleum products, use caution when drawing off the sample. Draw samples only with the manner product with the subcourse in this subcourse. Whenever working with a petroleum facility, always consider fire prevention. 4. Sampling procedures. Obtain the sample that represent the entire quantity of the product, unless otherwise the analyze your product will reflect the quality on only a portion of the whole substance, and the quality that is reflected may be better or worse than the true quality of the product as a whole. Normally, she should collect 1 gallon sample for the liquid product of the 5-pound sample for the semi-solid product. Collect 5-gallon sample of the specifically sampled gasoline sample. Use the test performance number, the supercharged method. Also collect 5-gallon sample of jet fuel to sample the thermal stability. Use standard sample to describe the paragraph after the one best suited with the product of the container carrier. Use improvised sample with a sample opening in the to the small to use the standard sampler. In any case, be sure you have a clean sampler and is made with the material cannot contaminate the sample. Samplers are described later in this lesson. Clean the sampler and sampler container, rinsing them with the product being sampled. However, do not rinse the items with the product if then taking with the sample the particular particulated containment sediment. Product of the samples the shipment protect the gasoline, jet fuel, kerosene sample the direct sunlight using the brown bottles, cans, and covering the clean bottles with paper or foil, keeping the bottles with gasoline, JP cool, cooled 30 degrees Fahrenheit. If possible, to prevent the loss of light ends, protect the samples when containing lead additives from the sunlight. As a serial number to each of the sample, the entire of the number of the sample, the log, the 2 digits of the calendar year, the sample, the number, the year to make the number. For example, the number 81 is the first sample for the activity of 1988. Number 88-2 is the next example to keep the station log with the record of the sample submitted with the designated testing laboratory. Maintaining a laboratory log is the permanent records of samples recorded, received for the testing, entering on a log. The date of the sheet, the type of the product, the unit sample, the number, the source of the sample, the quantity of the sample that represents the same, the number. Sampler's name, the date of the sample, the date of the completion of the test. Sampling equipment. You can obtain the samples of liquid petroleum products of the following 5 types of samplers. See Figure 2-1 for weighted breaker, the drum thief, the baking bomb thief, the weighted bottle, and Tulsa thief. A weighted beaker. A weighted copper beaker sampler consists of a copper bottle permanently attached to a lead base, attached with the stoppers and drop cord so that a quick jerk can often open the sampler to any of the beneath the surface of the product. The use of the sampler to obtain the top, upper, and middle, and lower, and all levels sample liquid petroleum products from all the tank of the cars, the tanker trucks, the barges, ship tanks, and shore storage tanks. The drum thief. The drum thief is a plastic cylinder. The tube type of the sampler consists of the 2 pieces of the single piece of the plastic tube within 39.5 inches long and 1.5 inches in diameter. The tube has 2 finger rings at the upper end of may have 3 supporting legs at the bottom. Both ends of the taper have openings. Use the drum thief to take some spot samples in all sample level of the drums and spot Spot samples closing the top of the opening with your thumb with it totally submerged with the sampler in the product, then removing the thumb from opening all the products of the fill in the tube from the level desired, using the drum from the thief of the drums and cans. For all samples, remove your thumb from the opening and submerge the tube into the product. After the tube fills with the place your thumb over the opening and withdraw the sample. The bacon bomb thief. The bacon bomb thief is the tanker car thief. It's a nickel-plated brass cylinder tapered with the bottom end fitted with an internal plunger valve. The valve opens automatically with the sampler strikes at the bottom of the container. When you lift the sample from the bottom, the valve closely automatically makes attached for the trip cord to make it possible to open the cylinder at any level. Using the bacon bomb thief to take bottom samples and take samples in the storage tank of the tanker cars and tanker vehicles. This shows the weighted beaker, the drop cord handle, the cork of the copper casing, lead base, the drum thief at the top opening finger pring in the tube and the bottom opening, the bacon bomb with the plunger cylinder valve in the trip cord and drop cord, the weighted bottle, lead casing, glass bottle, cork, and drop cord. The tubular tank thief for the Tulsa thief is the bottom sediment and water gauge with a single chain trip, and a slide opener. The weighted bottle glass cylinder sampler consists of a glass bottle with a square weighted bottle holder attached with the drop cord with the ring and the stop of the weight of the bottle weighted with the box. Brake samplers are used in the same manner for the same purpose. The only exemption is the weight of the bottle has the wide mouth and can be raised with the sample. Heavy light products, the weight of the product is used to sample. Only light products use the weight of the bottle for all the vapor pressure and oxidation stability samples. The tubular tank thief or the Tulsa thief. The Tulsa thief is the metal cylinder opens with the both ends. When you activate the closure, you seal the bottom of the cylinder, trap the product in the cylinder, activate the closing mechanism, mainly using tugging on the cord automatically by the touching of the bottom of the sampler. Using the Tulsa thief, samplers take the bottom sample in the storage tanks in the tanker cars and tank vehicles. 6. Sample containers. For sample containers, you may use clear or brown glass bottles or cans. Use the best suited type of the sample container with the product for the purpose of the test. As mentioned previously, the size of the liquid samples usually gauge from 1 gallon to semi-solids using 5 pounds. For special samples, for example, those that test the supercharged thermal stability, use a sample for at least 5 pounds unless the sample size is otherwise specified. 7. Sampling packaged product. For packaged product, when you need representative sample shipment when testing necessary, although you can obtain the guidance as how much product constitutes with a representative sample from your Division Material Management Center or DMMC. For the critical concerning with dealing with the packaged product that is submitted with the right samples. Packaged petroleum products are produced in batches. The batches are not equally divided in first by shipments. For example, 1 case of motor oil can contain more than 1 batch. Inspect each of the containers that you sample. One only affected batches. Your desired result is to send representative sample for the affected batches, not from a good batch. Also, you receive the test results concerning the samples, keeping affected stock away from the good batch, good products, so that you do not issue the affected stock accidentally. 8. Portable petroleum testing measuring kit. The portable petroleum sample and gaging kit shown in Figure 2.2. Bulk storage facilities use it for the following purposes. Gauge tanks measure product temperature, detect bottom sediment and water, and make volume calculations and sample fuels. Your ASTM method pamphlets for the carrying case, hydrometer cylinder, weighted beaker, sampler, brass-coated chain, image and tape in the bob, gravity computer, weighed water indicating paste, sample bottlings, gasoline indicating paste, bypass coated chain, cup case thermometer, cheesecloth, and a hydrometer. You can find the kit reference in Supply Catalog 668090CL901. It weighs 22 pounds and consists of aluminum carrying case fitted with the measuring sampling equipment. The major parts of the kit: olive drap aluminum carrying case, cup case thermometer of 11 to 180 degrees Fahrenheit range, inch tape in the bob, hydrometers ranging from 19 to 81 API gravity hydro cylinder with a removable base, weighted breaker sampler, weighted mouth, sample bottle, brass coated chain, gasoline indicating paste, water indicating paste, cheesecloth, gravity computer with the case, and American Society with the testing materials and tested pamphlets. 9. Sampling and testing requirements outlined in Military Handbook 200. The minimum sampling and testing requirements for determining the quality of petroleum-related products. If responsible cognizant petroleum officers to maintain strict quality surveillance, you may increase the frequency of the testing, consideration conditions, stockage, age, storage age, the stock type of the product concerned above. What is increased in testing conditions are warranted. The type of the test used in the testing product stored in the bulk at the installation depots are. These types are tested with the petroleum storage stored in bulk at installations or depots are type A, B1 and 2, B1, B2, B3, C, solid millipore, flashpoints, explosive, and visual checks. Further to the publication extraction appendix B, the table A1 displays the minimum frequency testing various petroleum products. For example, the table A1 shows the dormant bulk and package display fuels requiring testing every 12 months. The table A2 provides information about type of samples required. When you finish the sampling type of the test, perform the final page of the tab A with a brief descriptive of each of the type of the test provides additional information. Use the appropriate type of the test on petroleum products with stipulations saying that the inspector of the product at least annually with the discretion of owning and inspection authority that have regarded the type of the product, age, stock, and conditions of storing. 10. You can procedures. You can reduce the sampling to a simple set of procedures because of the many differences with the petroleum product transportation, storage, and sampling testing. Contact your subordinating laboratory for the specific guidance for the following procedure. Minimum precautions. Use an approved sampler, approved containers. Ensure the personal use, cleaning, sampling equipment and containers. Rinse the samplers and containers with the portion of the product being sampled to ensure that the product is not contaminated with a previous material. All right. Note that when a sample is sediment tested, use only the sample containers with the previously rinsed petroleum. Either do not use the container with the rinse with the product being sampled. Clean samples immediately used before taking the continuous sample. Draw enough to displace all the product with the sample lines. Take the samples from the hose after the discharge about 2 times the volume capacity of the hose. Do not fill the sample container above 90% of the capacity. Seal it tightly and use the clean dry cleanse brown bottles to protect samples of gasoline, jet fuels, kerosene from direct sunlight. Attach completely the form DA form 1804 petroleum sample tag to each container. Log each sample with its serial number, your facility, and informal sample log. You just see note when you receive the DA form 2077 petroleum products laboratory analysis report at your facility. Note in your formal log comply with any of the remarks before filling the form of the future reference. And that was Direct Gaging and Sampling Operations, the QM 3504 Edition A, Army Institute of Professional Development, Army Correspondence Course Program. Directing Gauge Sampling Operations.